All right. Should we wait a minute or two, Pope? What do you think?
Minutes so others can join us. We have more people joining us.
Okay, cool. We'll wait for a minute here then.
Kai, me suna okay.
And so, welcome to today's section. So today we have with us Shane, who is the head of content creation from Secret Network Foundation. And Shane will be taking us on introduction to blockchain technology and its keyword use cases or its keyword applications. Also, you guys get to understand the concept of decentralization and its impact on various industries. Also, you guys get to explore different types of blockchain and their use cases. And there will be a workshop here today after this section. And I welcome you guys one more time to today's section. And today is the first day for our section on the future, on the simplified decentralized future. I know most people might be wondering what is blockchain, what is decentralization, but our speaker tonight will be breaking it down so everyone can understand. Yeah, thank you very much, guys, and welcome in. We'll wait for 2 more minutes and then we'll begin. I believe team is ready.
Great.
Also, everyone gets to understand everything because this will be simplified and for beginners actually. So you guys get to understand how it works and how the whole blockchain ecosystem is. So yeah, thank you very much, Shane, for joining us tonight.
Absolutely. This has been an exciting event. Appreciate you and all the leadership putting it together. Yeah, excited to dig into this. And did I hear right that you want to wait a couple more minutes, or should we just dive in now?
Let's give it 1 more minute. Then more people are still joining us. 1 more minute and then we'll begin. I think we have more people joining us. 1 more minute and then we are live.
Great.
You have the mic and please let's kick off. So guys, welcome to the official section for today. Please, if your mic is on mute, please mute yourself. Welcome to the official section for tonight on the blockchain technology. So Shane, we have the mic, please. Let's begin.
All right. Yeah, thanks again for the opportunity. I appreciate Secret Africa leadership putting this together. It's really a great opportunity, especially if you're coming from a beginner level, like a level 0 understanding of blockchain. The events over the next few days and these talks, as many as you're able to tune in, it's really going to accelerate, take you from 0 to, I would say, an advanced understanding of blockchain, Web3, privacy, all of that. So great opportunity. Just a really quick intro on myself. I've been a part of the Secret ecosystem for 3 years, focused on marketing, communication, and content. And my goal is always to make important ideas easier to understand. And that is a tall task when it comes to blockchain, which is pretty advanced technology. But I'm not coming at this from a technical level as a developer and I don't imagine many of us on this call are either. So we're looking at this as far as how could you explain blockchain to your friends who have never heard of it before, or if you yourself are there. So just starting at that beginner level. So we'll dig in here. Something that's pretty cool to think about. Maybe you've seen a graphic like this before, but this compares and contrasts the adoption curve of the internet, which is the white line, with crypto users, which is the yellow line. And maybe you've wondered yourself before or heard people ask the question, well, is crypto really going to be a thing? Is blockchain going to make it? Is this a fringe technology that won't really get traction and won't be around a few years from now? And the answer to that is it's no longer even a question. As you can see from the adoption metrics here in this graphic, we are today, when it comes to crypto adoption, we are basically the internet in 1998. So if we were able to time travel back to 1998, there would be all kinds of different people saying different things about the internet, right? Some saying, oh, this is a fad. What are we even going to use this for anyway? Can it provide real value and use cases in the world today? And of course, now, fast forward to 2023, 85% of the world has a smartphone. So 85% of the world is accessing the internet every day, and we can hardly imagine living without it. We are on that same trajectory with blockchain. And that's why 52% of Fortune 100 companies, so these are the largest 100 companies in the world, 52% of them have blockchain initiatives, and that number is growing all the time. So you could argue from a business standpoint that blockchain has already been adopted even more than crypto has. Companies have seen what a powerful innovation this is, and they're already getting to work on integrating it into their business models based off its unique use cases and value for them. So with all of that established, sort of how big crypto and blockchain really is and the direction that we're headed, I want to look into the question of why. What is it that blockchain actually does at a basic level? And then decentralization. Why is that a value add? And how is it a part of the architecture of blockchain? So we'll talk through all of that. This is where we're headed as far as an agenda in the next little bit of time here. So I want to go back to what some consider a legend, but a story that in some sense is historical, and that is the Library of Alexandria in Egypt. Around 300-400 AD, Alexandria had one of the largest libraries in the world. There are different estimates as far as how many books and scrolls really were in there, but tens of thousands, maybe even close to 100,000. It was one of the world's largest physical accumulations of knowledge. But something happened, and it's this, pictured in this next picture here. The library burned to the ground. So one of the world's largest physical repositories of knowledge was destroyed in a fire, like a tragic incident. And regardless of the historical details of this and all of that, which is somewhat disputed, the story leads us to an important point, and it's this, is that when information is centralized, it has a single point of failure. There's a cultural proverb in some cultures, don't put all your eggs in one basket, right? Maybe you've heard that, but the idea is don't put everything of value in one location, because if you do, and that basket is dropped, you have no more eggs. You've lost it all. The same is true when it comes to knowledge, data, information, power. And so I want to be really careful when we talk about the potential of blockchain here, because it's very common to present any new technology, blockchain included, in sort of this sense of grandeur, and it can do no wrong, and this is going to change the world. And here's a truer representation of that, is that Any technology, blockchain included, has potential for good. But that technology also has potential for bad, for evil, for wrong. And the technology itself is neutral. It's just a matter of how it's applied or not. So hear me carefully on that. But blockchain technology is the potential to decentralize risk and failure. It's a better way to do systems, and we'll talk about why that is true. It offers the potential to decentralize truth and data. Rather than having all of the world's knowledge in a library that burns down, imagine if that knowledge could be replicated in metaphorical libraries throughout the world. It's a better way to do truth and data, and it offers the potential to decentralize ownership and power, which is also very attractive, and we'll dig into that a little bit. By the way, as I jump along in this, I'm not keeping track in the chat. I'm just sort of rolling with these slides, but we will have some question and answer time at the end before we jump into the workshop portion as well. So if you do have questions, feel free to drop them into the chat or just make a note, and we can definitely cover those at the end. So let's start with those promises or those potentials anyway within blockchain. Let's start to talk about how blockchains work. You can see the contrast here between on the left, a central computer. Imagine if there was a computer that had all of the knowledge in the world. That would be a powerful computer, of course, and it also raises a lot of questions and a lot of problems. For example, who gets access to that computer? What if somebody has motive to manipulate that data or to change it for their own selfish gain? Who gets the password? What if that computer were destroyed or corrupted or lost? All of these questions come about when data is centralized, like with this centralized computer on the left. But what a blockchain is more like this image on the right. Some define it as a community computer. A community computer, you can see there's even, I don't know if you can quite catch it on your maybe mobile screens with the small graphic here, but these little green checks, these computers are checking and balancing each other to make sure that their shared representation of the knowledge is accurate. And if one of these computers were destroyed, theoretically, that's okay, because all the others are like a backup. If somebody hacked one of these or hijacked one of them, it would be okay, because it's not all dependent on one device, like with the central computer. So that's a really introductory way to think about how blockchains distribute data and knowledge. Some people like to say that blockchain is a self-replicating state machine that can continually prove its own state. I realize that's a big jump, but here, let's check it out with this graphic, and you can kind of imagine in story form how that plays out. So let's say that you want to execute a new financial transaction on the data or on the blockchain. So maybe you're buying an NFT or buying some Bitcoin, whatever it might be. You go to engage this transaction. It's new data, and that data is getting dumped into a block, like think of it as a link in the chain. This new block that's going to be created here by the chain, and within that block will be all new data about what's happening on the chain, what's happening within the network, which includes your transaction, right? And so that block is in the process of being created. The block is broadcast to all the nodes, or think of it as all the computers in a sense in the network. And then once that community computer, once all of the nodes approve that new block, your transaction is forever encoded into the blockchain. It is approved permanently. And sort of like a physical chain, it's this new link that's added on that can't be changed. It's there forever. Every new block is a verified proof of the state of the chain. So what blockchain is then is, and again, I don't want to make too big a claim here, but it's kind of a new way to do a source of truth. Rather than having to trust a centralized computer or a centralized entity or a certain individual who's managing data that can be manipulated, we have the ability with this technology to decentralize that data in a way that is trustless. That's a big word when it comes to blockchain. If the chain is doing its job, we don't have to trust anybody because we can verify everything when it comes to the state of the chain. So you can start to see some of the power here when it comes to blockchain as a new way of doing data and a source of truth. Let's take a breath here. I know that's a lot. We're going to jump into, and this might be kind of the most technical part, so really kind of dig in, and if you're able to track with me, we're going to talk about the layers of blockchain architecture here at a very simple level. So, and if you can stick with this for the next few minutes, you will be a blockchain wizard. You'll know quite a bit. So when it comes to blockchain architecture, if you wanted to build a blockchain, for example, at a basic level, what are the components? What are the different pieces that are part of that? The first layer is just hardware. These are the computers that are doing the computing. These are the machines, in a sense, that are making the blockchain possible, because, of course, a blockchain can't come to life without computation power, without computers doing the functions that are necessary to execute the network. So that's the hardware level, pretty easy to understand. The second level of blockchain architecture here is data, and that is the state of the chain. It's that decentralized ledger that we talked about. If you want to imagine it with an image, you could just think of it, again, as an actual physical chain. That's a good picture of what the data on a network is here. And then the network itself. Here's a great image to think about what a network looks like. So in a centralized network, here on the left, we have this huge dot in the middle. You can tell just intuitively from this graphic, like this is the most important node. This is the most important dot in this centralized structure. If this dot were eliminated, what happens to this kind of network? Well, it dies. There's nothing left. But in a blockchain network that is decentralized, which is always the goal, it looks a lot more like this. And there are different network participants, different nodes is what you would often call them, that are represented by these different dots. And if you eliminate this one, the network's still okay. If you eliminate that one, the network is still okay. It's still sustained. And so fundamental to the idea of blockchain architecture is this decentralized system of network participants where ideally no single node is more important than any other. So that's the network level. And then consensus. Maybe you've heard this idea of consensus before when it comes to blockchain. Consensus is in many ways like the security layer for a chain, extremely critical. And there are different consensus mechanisms you might have heard of. We won't spend hardly any time talking about this because it does get pretty deep, but proof of work, Bitcoin is proof of work, Monero is proof of work. That means that on those chains, nodes secure the network with computing power by solving puzzles to gain authority for new blocks, and that's mining. You've probably heard of Bitcoin mining or Monero mining. Other chains are proof of work. Proof of stake is a distinct, it's a different way of doing security for a network. And delegated proof of stake is actually like kind of a subcategory that's slightly different of that. But basically, in a proof of stake network, a node, pictured by, again, one of those dots in the decentralized network, a node would lock up tokens like Ethereum, for example, and that's called staking. They're locking up economic value. And in proof of stake, those who have the highest stake, those who have the biggest investment in the network, they earn the right to validate blocks. And there's some small differences in how that plays out between like delegated proof of stake, but we are not going to get into that in blockchain basics here today. But that's the basics on consensus. And then applications. This is really the fun part of blockchain, right? This is the smart contract layer where people are building cool innovations that allow you to do things on the blockchain. This is where use cases start to come into play, right? It could be NFTs, it could be a blockchain game, it could be a financial application, a decentralized exchange. More and more use cases are being developed all the time, but these applications are how you interface with the blockchain via smart contracts. The last piece to understand of blockchain architecture is that really unites all of these is the token itself. For example, Secret Network has all of these layers: hardware, data, network, consensus, applications, like over 50 applications, I believe, on Secret Network at this time. And token is really the secret token comes into play on all of these. It's used for gas to help execute transactions on the network. Think of it like oil or energy. It's used to participate in governance. It's used on all of these layers. Tokens are really the economic incentive layer for the blockchain and human actors to perform their necessary functions. Otherwise, if there weren't this economic incentive layer, people would be less inclined to participate, right? Let's be honest, a part of what is attractive about blockchain in this emerging space is the economic possibilities. And a blockchain's token or gas token, utility token, it allows for that if they have good token economics. So that's probably enough when it comes to blockchain architecture. I realize it's a whirlwind tour, but hopefully you're catching some pieces that are helping you connect the dots about how blockchains work. Let's move into something that's a little bit easier to understand, more of a social concept, and that is decentralized systems, this idea of decentralization. There is a book called The Starfish and the Spider on the nature of decentralization. It's by Ori Brofman, and that's a great read if you are looking to dig into more about what makes decentralization distinct. But the title itself really tells us a lot here. If you take a spider pictured here on the left and you cut off the spider's head, the spider ceases to do spider things. It can no longer be a spider. Its existence has ended. However, if you take a starfish and you cut off a starfish's arm, something very amazing happens. That arm is replaced, it grows back, and then the arm that's been cast away somewhere else, that turns into another entire starfish. With the spider, its head is the central command system. And when it loses that, it's done. But with the starfish, it's a unique organism in that its command system, its central operating system for living, is distributed throughout its entire body. So cut off an arm, and you've just created another starfish. It has replicated itself. And that word picture, or that idea we see within nature, is a really powerful way of understanding the magic of decentralization. What's special about it? When we think about decentralized systems, it's important to realize that decentralization is really an ideal. It's a spectrum. So when every chain says, "Oh, we're decentralized," we all have to do our own diligence, do our own research on that to see whether or not that is actually true, because no blockchain is perfectly decentralized. We'll talk about a couple examples of that in a minute. But the more decentralized a chain is, the better it has distributed risk and power throughout the network. That's an important phrase to understand here. If we go back all the way to the power and possibilities of what blockchain can promise right here, again, this technology offers the potential to decentralize systemic risk, to decentralize truth and data in a way that doesn't require trust and can't be manipulated, and it's the potential to decentralize ownership and power. So that's what we're digging into here. And again, this image is like, when you think of decentralization in your mind, it should be kind of a picture like that. A blockchain should be a distributed network of nodes where each of them are basically hold a copy of the blockchain. All the nodes are checking and balancing each other, making sure that the state of the chain is accurately represented. They're coming to consensus. They're coming to agreement about the state of the chain and whether or not new data is actually true. So that's the idea of decentralization. There are a couple ways to measure this, two that we'll talk about here. The first is called the Nakamoto coefficient. And the Nakamoto coefficient measures the minimum number of nodes that could disrupt a network. So going back to this figure here, if we chop off this dot, the network's hopefully okay. If we take away this one and this one and this one, is the network still okay? Well, it depends on how decentralized it is. So the more decentralized the network is, the more nodes you could take away without disrupting a network. That's one way to understand or to really quantify how decentralized a network is. And here's a second that I think is even easier to grasp. And this one is economic. So token supply distribution shows how equitably value is distributed in a project. And again, when you're looking at chains or projects to get excited about and potentially become a part owner of, which is what's so amazing about tokens in crypto, right? Is when you own a token for a project, you are a part owner of that, which is really, really neat. However, you want to be careful in taking a look at how fairly and equitably token supply is distributed throughout the network. I would venture to guess that almost everyone here today has heard of WorldCoin, which has been in the news many times over the last few months. WorldCoin seems to say we're going to do something good for the world, right? Scan your retina in this orb and we'll give you some world coin, about $50 US worth, and our blockchain will help prove humanity, help make sure you are a human being and not an AI. That's kind of the rough mission statement for them, right? They want to make it sound pretty good. But then if you look, information is publicly available on Etherscan, which is a blockchain explorer. 90% of all of the world tokens are owned by 7 wallets. And there are, the last I looked, just over 6,000 people who are holding WorldCoin. So at least for me, this isn't financial advice. I'm just using this as an example, and I'm speaking for myself. But I don't get excited about investing and being a part owner in a project where 90% of the economic value is owned by 7 people. That just doesn't sit well with me. That doesn't seem right to me. And so going back to this point, when we talk about decentralization, token supply distribution is part of how we can evaluate how decentralized a project is. And I think that probably makes good sense. Let's shift a little bit to talk about use cases for blockchain. And okay, so wow, this is amazing technology. It's kind of a new way to do data. It's almost like a new operating system for the internet. You know, wow, decentralized ownership, all this good stuff. What could we use it for? Well, this is just a tiny list compared to the tens of thousands of opportunities that exist for blockchain. Finance and DeFi is a big one that comes to mind. Ready-made logistics, AI, Internet of Things, real estate, real world assets, intellectual property, and making sure that it's verifiable, gaming, art, entertainment, media, biometric and fitness data. And we could probably add 40 more things to this list. So I just said this instead. Uses cases for blockchain, anything with data. I mean, it's like someone asking, is there really a real world use case for blockchain? It's like saying, yeah, is there a use case for the internet? Is there anything that we can do with a laptop computer or with data storage? There are just tens of thousands of use cases possible for the blockchain. But to this point, there has been a missing ingredient in blockchain so far, and it's a critical ingredient for us to be able to continue to move forward and see the kind of mass adoption that we hope for. And so let me tell a little story for that to help picture this. By the way, if you have a hot mic, yeah, just go ahead and mute if hot for now. Thanks. So yeah, I was headed out to lunch one day with the founder of a large multi-million-dollar Ethereum project. And I didn't know this person very well, but I thought, well, you know, we're getting together, I'm curious. And in my mind, I decided to do a crazy experiment. Because this person used an NFT for their profile picture on Twitter or X, right? I took that NFT and I clicked through to OpenSea, an NFT marketplace, to see the wallet address for who owned that NFT. It took me 60 seconds. Once I had the wallet address for that NFT, I could see every asset this individual held. I could see every single token, how much Ethereum they held. I could see their financial history, their highest balances, where, you know, when they had cashed out, when they had made trades. I could see associated wallets that they had sent funds to, which potentially some of those wallets could belong to them as well. I essentially had this person, within 3 minutes, I had access to this person's entire financial history on the blockchain. And this isn't unique to Ethereum. This is the best word to describe it is transparency, which sounds good as a human value, right? But when it comes to our data, things start to break down. Data transparency is only acceptable for a very small number of blockchain use cases. However, 99% of all blockchains are transparent. And so for us to get excited about migrating the future of finance, for us to say, oh, crypto is a new economic world order and we're moving it online, we're moving all of the world's finance online, that doesn't really work so well with complete transparency, right? I shouldn't be able to go look at all that information and have it be publicly available. I shouldn't be able to do that any more than someone should be able to come inside your house, open up your refrigerator and start digging into your food. we shouldn't have this data be transparent any more than you should be handing out house keys to random strangers on the street. This is not a viable way for us to see blockchain into the future. So here I have a little video that I'll play and just kind of talk you through it here. The way I was able to get all that information and the way that a blockchain is explored is through something called a blockchain explorer. This one is MintScan, mintscan.io, which we may do a little something with later today. So you could go to mintscan.io right now and you could click on what network you wanted to see. This happened to be secret when I filmed the video. And you could click on transactions like I did up there at the top, and it will populate all of the most recent transactions. It'll tell you whether the transaction was successful, the transaction hash, which is a unique identifier for it. You can see a little bit about the nature of the transaction itself here, the amount, the block height. So that basically means what block it was included in. All of this is publicly accessible in the Cosmos ecosystem, on MintScan for the 60 plus chains that are here. In the Ethereum ecosystem, it's etherscan.io. Every blockchain has a blockchain explorer. And so that's kind of what we're seeing here. So there's a problem with that rigid transparency, though. If you look at how data is handled on Secret Network, for example, it's something very different. If you're sitting here at your computer and you want to make a buy or a swap, do some type of transaction, your input is encrypted and sent to, think of it as like a giant swimming pool almost, where the nodes then are picking that data out and validating it. But something very cool happens here on Secret is that encrypted data goes into, think of it as a black box called a TEE, a trusted execution environment. So even when a node is processing, handling, validating your data, if your application that you're using on Secret is taking advantage of privacy, then the node isn't going to see that data. Your data is confidential. It's private. So it's private on the way in. It's private inside the trusted execution environment as computation is happening, and it's encrypted on the way out as well. Then that data is sent. This is the consensus layer that we talked about earlier. All validators are going to perform consensus that your transaction should be included in the next block, which on Secret takes 6 seconds for a new block. And on Secret, when 2/3 of the voting power reaches consensus, that block is committed, it's validated, and then all the way back here to your computer, you can see this tiny little green, hey, awesome, your transaction has been approved. And you can now query that transaction result on Secret through something called viewing keys. And viewing keys allow you on Secret to be in charge of your data so that you decide who sees your balances, your transactions, your financial history. Not just some random person who happens to get a hold of your public wallet address and they can go see all of that. Nope, on Secret, you get to be in charge of how that data is managed when you're using applications that take advantage of privacy. So that's pretty cool. Privacy really is this missing ingredient as we move into the future of blockchain and what's possible for it. Without privacy, blockchain is like living in a glass house. Everything you own, everything you do, every application you interact with, that can be seen by anyone. And that's not how human beings live. That's not a healthy way to live. We don't share our deepest secrets at the marketplace with the person we're buying our groceries from. We don't hand out copies of our house key to random people on the street. We don't print out copies of our bank records and give those to anyone who's curious, who wants to look. So why is transparency the norm on blockchain? It can't be. It can't be. And that's why if you talk to Ernst & Young, which is a $45 billion consulting company based in the United States, their head of blockchain in this last year has said, yeah, most of the world's largest companies, they're very excited about blockchain. They're just not going to come on board without privacy. Could you imagine an Uber or a taxi service where your address and how much you spent and your bank record, all of that is publicly accessible? It just doesn't make sense. So the world's largest companies, as we saw already, those who don't have active blockchain initiatives, they likely will, but they're just waiting for some level of privacy in order to make it happen. Privacy is this missing ingredient, and that's why privacy-preserving blockchains like Secret, they really do more than decentralize data. We talked about, oh, it's so great to be able to decentralize risk and truth and power and ownership. That's great. But if you're doing all that in a transparent way, even if it's decentralized, you are still susceptible to surveillance. You are still susceptible to data mining, to your data being abused by people who, whether it's large organizations who want to know or just somebody else who's curious and is digging around. That's not right. And that's what is unique about what Secret is up to when it comes to blockchain data. So that's what I have for today as far as talk time. I'm happy to dig into some questions in just a minute. But if you want to stay in touch, you can follow me on Twitter with my Twitter handle here. I'm Sean Merrick. And yeah, I hope this has been a helpful way to get a nice introduction to what decentralization is, how blockchain works, and getting you up to speed there. Hopefully now you're better equipped to explain it to family and friends and even your own understanding. So that's me. I'm gonna pull back up the chat here and get ready to answer some questions if there are any. And also invite Pope Black too to kind of co-host and MC with me here as well. What other types of privacy blockchain are there? Oh, that's a great question. Not unfair at all. Yeah, there are. I think the best way to explain that is that there are many different types of privacy preserving technologies, each with unique benefits and trade-offs. If you go to scrt.network and this is pretty deep, but if you were to search beyond ZK, there's a giant article there comparing and contrasting the trade-offs of different privacy technologies. Some people don't like the idea that a trusted execution environment is a hardware dependency. It relies on this physical piece of technology that's created by Intel, in order to execute privacy. Some people talk about zero knowledge proofs as if they are some sort of magic bullet, holy grail that can do everything. But the reality is that zero knowledge technology, while it is great for transactional privacy, it can't execute cohesive computational privacy throughout an entire ecosystem. So there's some deficiencies there. There's multi-party computation. There's fully homomorphic encryption, like the new sister chain to Secret, Phoenix, which you may have heard about. So all of these different privacy techs have unique trade-offs, and different projects are experimenting with all those. What's cool about Secret is we're building this constellation of privacy chains, privacy tooling that rather than just saying, oh, this one solution is the best, this is the way, we're really trying to create options for builders and for users to take advantage of whatever privacy solutions make the most sense for their use case. So that's pretty cool. For this workshop here, don't miss Pope Black's message in the chat. If that's something you want to participate in, go ahead and focus in on his instructions there. Another question, shouldn't one of the most amazing features of the blockchain, shouldn't be one, why then take part of that transparency away? Yeah, so I think the question, if I understand it right, is, isn't transparency powerful and helpful? Doesn't it have some benefits? And yeah, sure. I mean, Bitcoin, the original crypto, right, is transparent. So unless you're using it with some kind of privacy layer, any transaction you do on Bitcoin is, people are going to be able to look that up. They're going to be able to query it, which means that when you use Bitcoin, you are operating with less privacy than cash, because everything you do is trackable. It can be seen. And so while that transparency is great for some use cases, I don't think, and this is just my personal opinion, everybody can come to their own opinion on that, but it doesn't make sense for the vast majority of use cases, because think about the way that we live our lives as humans. We have layers of permission and access. You tell certain things to your partner or your friends or your children that you don't shout out on a busy street. We all have different layers of relationship, layers of access, layers of visibility into our lives. But right now on blockchain, the norm is everybody sees everything. Your financial history, what NFTs you own, what applications you interact with. And as more and more of our data moves on chain, that just doesn't make sense to me. That's my answer to that. Is it necessary to have a token to carry out a transaction in blockchain? How can we get a token? Yeah, so if you're performing a transaction on Secret or on Ethereum, for example, a little bit of the token on the chain that you're transacting on will be used for gas, which is often a fraction of a cent, or a couple cents, depending on the chain. In the way that you could access that, after this, maybe I'll dig a tutorial out for you and drop something in the chat here. That's a great question. You're basically saying, how can I get started? How can I get the token? And we can help with that. Oh, and Pope Black has a good answer here too. What other questions? Are there any other consensus mechanisms apart from proof of work and proof of stake that enhance decentralization? I don't have like a highly intelligent answer on that. There are other mechanisms. As far as, are they better for decentralization? I think it would be difficult to argue that. I did recently bump into Caspa, which has pretty novel blockchain architecture and kind of doing some cool things there. They're certainly decentralized more than most projects, but yeah, I don't think I have anything else there. Most use cases require privacy. Yeah, great point here. For example, a company wouldn't want my competitors seeing my suppliers how much I pay for goods. That's exactly true. I mean, could you imagine a company having their payroll public to where everyone is seeing not only how much each employee is paid, but they can then look at that employee's wallet and see how much the employee has in their wallet? That just doesn't make a lot of sense. All right, another minute maybe for some other any other questions that we might have, and then I'll probably hand it over to Pope here. Oh, great question. Yeah, I'll answer this one real quick. If blockchains are private, then how can it be auditable? So with Secret, this technology called viewing keys a viewing key is like think of it as an actual key that you hold. This is what allows you to see your balances, your transactions, your history. So you've got that viewing key. And let's say that you wanted help doing your taxes. So you have an accountant, and you could give them your viewing key so that they could audit your transactions, verify your balances, all of that. So like a physical key, you can give that to anyone that you want, and they can then go in with that key and prove and audit balances and all that. So it's pretty cool stuff. And some other privacy projects do have similar technology as well. Okay, thanks for the great questions.
Let's keep the questions coming in. If you have any questions, please do feel free to ask. We have Sean here to answer our questions. Also, I believe everyone also is ready for the workshop. So during this workshop, we'll be sending tokens to one another. So you guys can see how it's sent on the blockchain and how transactions are being recorded on the blockchain. And the immutability of the blockchain as well. You being unable to edit or compromise what token you receive or the value of the token. Also the transparency level as well. And you guys get to interact with Secret as well, whereby you guys will see send tokens privately without revealing the details of this token to another person. So if you are ready, make sure you follow the instruction that is pinned on this Telegram channel. So download the tools needed for this transaction, for this workshop. And when you're ready, just drop your wallet address. Then each and everyone will be sending token to themselves. So you guys will see how the blockchain connects one another to each other. How the chains are being connected and so on. Yeah, and thanks so much to our speaker for today's section, Shane. This section has really been wonderful, and yeah, thank you very much. And it was really simplified. I personally have gained some knowledge from what Shane has taught us tonight, and I believe every other person here has also gained value from what Shane has taught us. And for those who might have missed it, this section has been recorded. It will be uploaded on the YouTube channel. And I don't know if Shane would love to share his slide with anyone. Some has been asking if they could have access to the slide. I don't know if Shane is going to be sharing it, but if he's not, you can still watch the video on YouTube as well. So I believe, okay. I don't know if you guys are ready. Okay, Shane is going to be dropping link to the slide here. So you guys can also check out the slide by Shane as well. So are you guys ready for the workshop? If you are ready for the workshop, kindly signify in the message chat, please. Thank you. So please don't forget to follow Shane on Twitter. Yeah, I've dropped the link to his Twitter. Yeah, so don't forget to follow him to give more knowledge regarding blockchain privacy and other use cases of blockchain. Okay, if you are ready for the workshop, all you have to do is drop your wallet address. So these guys going to be, I need everyone's attention. So once you drop your wallet address, I'll be sending the token to you. And once I send the token to you, you are going to be sending it to the next person that drops his wallet address. And the next person will be sending this token to the next person that drops the wallet address. So you are forming a chain together here. So, and also you guys get to verify who has received this token and who hasn't. Because we'll be able to check it on the blockchain explorer and tell the value you are transferring to this person. I believe everyone is ready. I think one person has. Okay. Drop your wallet address if you are ready, so we can begin today's section, today's workshop. Also, tomorrow we have another section on Web3, which is one of the use cases of blockchain as well. So the Web3 is more like the internet, but in this way, it is decentralized. So tomorrow the section will be on Web3. It's more like a decentralized internet whereby everyone owns their data on the blockchain now. On internet, you're in control of your data, and no central authority is marketing or selling your data to marketers or advertisers. So tomorrow you guys get to understand the core concepts of Web3, the use cases of Web3, applications built on the Web3 ecosystem. But for tonight, let's go into the workshop. Okay, I've seen several wallet addresses being dropped here. Okay, I'm going to be starting with Boy BTC. So Boy BTC, I'm going to be sending you to SRT. Then you're sending me to the next person, which is Peace of Mind. I hope everyone is ready. Okay, let's go. And I'm going to be dropping the transaction hash of this workshop so you guys can keep track of it and see who has received these tokens and who is sending this token to. So you guys get to understand how the blockchain works and the transparency and the immutability. It means no one can just say, okay, I didn't receive this token, or the value you sent to me was not up to this. No, everyone can see and verify this on the blockchain. After that, then we'll see how privacy plays a role in this as well. Thank you. I'm about to send tokens to Boy BTC so that I see it, so you guys get to understand how everything works now. I'm doing that now, just a moment. Alright guys, I've just sent Boy BTC to SCRT. So SCRT is the native token of Secret Network. So Boy BTC, I've just sent you to SCRT. So this is what you are going to do. You are going to send it to SCRT to the next wallet address after yours. So the next wallet address is going to be sending to SCRT. That's the probably 1.8 SCRT to the next person. And this is how we continue. So Boy BTC, the transaction has been confirmed. Please send maybe 1.9 SRT to the next person as well. Thank you.
Okay, just sent mine to what's the name? Peace of Mind, yes.
So Peace of Mind, they've sent to you. So please send it to the next wallet address after yours. Do you know how to do that? So share your screen, you're all here to guide it. Okay, so Peace of Mind, you're going to send it to David Kolawole, then David Kolawole is sending it to Abdul, then Abdul to Local Bushman. This is how we keep it going. So let's go, guys. Peace of Mind, please kindly send it to the next person. So let's keep it going. I'll be sharing the transaction hash so everyone can keep track of it. So you know where the wallet address is now. Where the tokens are and who is holding the token and who is sending it to another person.
Sorry, I wanted to ask, where can I find the transaction hash on Fina Wallet? Hope, did you hear me?
Okay, you can check your just on the Fina mobile wallet. Click on there's a symbol that looks like a signal. Click on that signal. You can see the token you sent. You can check your transaction history. Also, I've just dropped the hashtag. Sorry, the hash transaction for the token you sent. I've just dropped it now. I've sent it to the message so you guys can check it as well. So now, Boy BTC has sent the token to another wallet address so everyone can keep track. So Peace of Mind is going to be sending it to the next person as well. So now I've just dropped a link. If you guys click on the link, now you guys will be able to see what transaction occurred, the value of this transaction, and who this transaction occurred with, the sender and the receiver. Okay, so Peace of Mind, I've sent it to another person. So now, if you want to keep track of that, check out the address, and then you're able to see who Peace of Mind sent this token to. So this is how the blockchain transparency and immutability works. So now, peace of mind cannot say, okay, I didn't send this to him, or David cannot deny that he didn't receive any token from. He can't deny it because everyone can see it. So he can keep track of everything going on. So transparency is good, but to some extent, there are some, downside of transparency. As a person, I don't want my financial record to be public to everyone to see. I would love some sort of privacy over it. I just want all my neighbors or all my friends or all my classmates at my university to know how much tokens I owe or what are my value. So I will need some sort of privacy on that. During this workshop, you guys will get to understand how both transparency and also privacy plays a role on the blockchain, and how the blockchain record transaction and how the transaction are being validated by validators as well. So we use some analogies for everyone to be able to understand. So David Kolawole, I believe someone have sent you these tokens. Please send it to Abdul now. So Abdul can send it to local Bushman. Then this is how we keep going. Thank you. So I want everyone to interact with the blockchain, see how it works, and you guys can have experience of everything you need to know.
Okay, I just received from Peace of Mind, so I'm going to send it now to the next person. As Abdullah, I think.
Please do send it to the next person, and this is how we continue. Okay, do you know what? I'm also going to be sending to someone else so we can make this very, very fast. I believe everyone is seeing how it works now. How send from a wallet to another wallet. This is simple, easy. I told you guys, the blockchain is not anything too technical, or it's not something everyone can understand. The blockchain, it's just like your WhatsApp, your Facebook, your mobile banking applications. These are technologies, and most of this technology makes our life much more easier. It helps us, to be able to build much more robust ecosystem. Like, most people don't really understand that the WhatsApp you use, the Instagram you use, these are all Web2 applications. And these are owned by and controlled by a centralized body or entity. But tomorrow you guys get to understand what is Web3 and how decentralization plays a role in Web3 as well, and some of the applications built on the Web3 ecosystem. So let's keep it going. I believe David is going to send it to now, then I will also send it to the next person. So there's nothing hard about the blockchain. This is something everyone can understand. It's a ledger where all these transactions are being recorded, and applications are being built on it as well. Like, there's this analogy I usually use. Now, this is how the blockchain works. So just imagine the blockchain like a Google Play Store or an Apple Play Store. So, like Apple Play Store, you can go into the Apple Play Store and download several applications from Apple Play Store or from Google Play Store. So the blockchain is just like the Play Store itself, where you can download several applications and where applications can be built on it or added to it. So the blockchain allows everyone, it's permissionless, it allows everyone to build applications on it or to download applications from it to interact with several applications. So it's more like a platform where everyone could come, build on it. There are several use cases to it, just like your Apple Store or your Play Store. We have finance tech applications on it. There's fintech applications on it. We have gaming applications on it. We have wallet applications on it. We have social media applications on it. We have various applications on the Play Store, and these have several use cases. They have their own unique use cases as well. They are being used for several things. And the Telegram you are using now, it's been downloaded from the Play Store. So the blockchain is like the Play Store, and most of these things are being done on the blockchain. It's been built on the blockchain. But you guys get to understand more about it during the other series of the workshop and also the educational section. So as soon as we are done with today's workshop, tomorrow we'll be having another topic on Web3 and what you guys need to know about Web3, the apps being built on Web3, how they work. Then subsequently, you guys get to learn about some of the some other tech stack being built on the blockchain, such as the DeFi, the NFT, the gaming, the DAO, AI, and so on and so forth. The blockchain technology, it's kind of broad. Yeah, there are a lot of things to learn from me. There are a lot of infrastructures being built on it, and this will be simplified for everyone to understand how it works. So, David, have you sent it to Abdul? What are going to do? You need a gas fee to be able to approve your transaction. So if you don't have enough gas fee, all you have to do is to send a lower quantity of the token. Probably you might send maybe 1.7 FTRT to the next person. So you can have gas fee to pay for the transaction. Just like you want to send money to someone, you need to pay a transaction fee. So on the blockchain, there's what we call gas fee as well. You need to pay gas fee for the transaction to be approved. So yeah, you can send a lower amount, probably maybe 1.7, to make sure you have gas fee to pay for the transaction. Also, this section is very exciting, guys. I'm going to share my screen, though I'm using the PC here, but I'm going to share my screen to see how it works. So you guys can see that I'm sending from one wallet to another. Okay, let me share my screen. Okay, let me share this. Hey guys, I'm sharing my screen. I'm going to be sending it to Kate now. So Kate will be able to send to another person. So like I said, it's very, very easy. It's not something technical or hard. So just a moment, just a minute. So let me just say okay, so this is how I'm going to send it. I have an extension here, so I'm using my PC. I'm using the Kepler extension on my PC. But on mobile, I use either Fina Mobile or I use Kepler Mobile. And the other several mobile wallets you can use as well. Okay, so this is it. Okay, I'm going to be sending to Kate now. Okay, I'm going to be sending to Kate. I believe everyone can see it. Okay, just a moment. Okay, hold on. Maybe maybe it's your network. It should work. I think you need gas fee to pay for these as well. Maybe try sending 1.5. You have insufficient funds. So maybe try sending less. Send it to someone else. I don't know why the network is a little bit slow. Yeah, okay, I'm going to send it. Sending it to Kate now, so it's going to send it to the next person in just a minute. Okay, I hope everyone is following. Don't worry, everyone is going to receive token tonight, and you are going to send to someone else. So this is just to show you guys how it all works. All right, so let's keep on sending it to one another. Let's keep it going. So by 7:30 we'll be running off.